We're in project cost management, and this video clip is about cost estimating. Cost estimating is part of the planning process group within cost management, and we'll have a word about plan cost management as well. So the process plan cost management means that at the beginning of a project, we're planning how are we going to carry out our management of costs. How will we estimate the costs? What sort of detail will we estimate down to? How will we approve expenditures? How will we track those expenditures? How will we monitor what project costs are? How are we going to monitor and forecast into the future project costs? That's what we decide based on the suggested tools within cost management. That's what we decide, and that's what we include in our project management plan. So estimate costs is defined as determining the approximate monetary resources or money to complete the project. And by the way, in terms of terminology, cost is different from price, at least in our context. If I'm the project manager, I am estimating and managing the cost that it takes me to carry out the project. If I'm doing this project for you, the customer, I will have some way of charging you, the customer. That will be my price. And price isn't necessarily based directly on the cost. Well, it may be based directly on the cost. It may be a straightforward flow-through of the cost. It may have a percentage markup. These are things that we talk about in project procurement management. Or price may be determined by what the market will bear, or what is it worth to you. Price is determined partly on what's the competitive environment. Now, we do use the word price. When I do use the word price in the context of these video clips, I'm usually talking about what is a supplier charging me as their price for work they're doing as part of my project. But then once they do charge it to me, that is my cost. So cost is how much we're spending to do the project, and price is how much are we charging for that product or service to the customer. Now, how we determine that price is a business decision that we're not including here in our discussions about managing the project. Now, there are some well-recognized techniques of cost estimating. And these methods are widely used across virtually all types of projects. When I talk to project managers, whether it's from entertainment or from various areas of engineering or from the business world or information technology, they all can say, yes, I do use these 3 methods or 4 methods of cost estimating. The first one is analogous or top-down. So we want to know what is going to be the cost of an upcoming project. And we did a similar project 2 years ago in Montreal. And we know, because we had good cost management, we know exactly what that cost us. Well, we take that cost from the project a year ago, adjust it by any inflation that's happened since that project was finished, also adjust it by any price differences we expect between Montreal and where we are now. And maybe I have to add on something for an extra feature, or maybe I take something away because there's something we're not doing on this project. So with a few adjustments, I can come up with an estimate for this project that may actually be pretty accurate and didn't take very much work. We would call that analogous because it's by analogy to one or more projects. Or you can call it top-down because we're not getting into the detail. Another method is parametric estimate. Here, there's one or more measurable characteristics. For example, a friend of mine is a cost estimating consultant for architects and engineers. And he might get a phone call from an architect who says, hey, Bob, we just got some good news. We got awarded a contract. We'll be doing a hospital expansion, and we want you on board as our construction cost consultant. Well, Bob will get on the job right away on the telephone. He'll say, well, how many square meters is it? And the architect will say, because even at this very conceptual stage of the project, there'd be an idea of how many square meters of floor area. And then Bob will say, what kind of space is it? And the architect will say, it's ambulatory care. Well, that just means for walk-in patients into a hospital. So Bob can immediately give him an estimated cost for the construction, design and construction of that project. And it's based on the fact that Bob, in his head, has parametric estimating model, basically, that says it would be this many dollars per square meter of space for hospital ambulatory care. Now, this is not necessarily going to be very accurate, but it can be very convenient to have an estimate quite early based on some measurable characteristic like that. Sometimes I talk to registered land surveyors, and when I talk to them about estimating, they'll all give me an example of parametric estimates. They'll say, well, sometimes our land surveying assignment involves cutting a line through woods or through brush. And they say, and we always estimate that by so many dollars per kilometer or so many dollars per meter to clear a line through the brush. Even without having to look in detail at the assignment, that's a pretty good basis of their estimate. Or any other time when there's some measurable characteristic that you know early in the project that defines how much the project will cost. For example, in ore processing, so many dollars per ton processed through the process plant in a period of an hour. Another one is bottom-up estimate. We call it bottom-up because this is literally from the bottom up. We have a detailed work breakdown structure. All the project is covered by that work breakdown structure. Each work package is estimated and we add them up. So it is probably more accurate than the analogous or the parametric. It's certainly more detailed, and by the way, it lends itself better to turning it into a budget. Now, a couple of things to say about the bottom-up is it can be very dangerous to try to do a bottom-up estimate unless you do have a good description of the project. If you're not sure what all the work packages are, don't try to do a bottom-up estimate because there's work you're going to miss. Another thing about bottom-up estimating is that each work package that you're estimating, some of those work packages you may work out from scratch. Well, I think it'll be one engineer and 2 technologists, and it's going to take them 2 weeks full time, and you work out with dollars per hour and you come up with an estimate. But for some work packages, maybe you're using parametric. Oh, we're going to be installing a stainless steel pipeline. So many labor hours per square foot. And by the way, an elbow is the equivalent of 6 linear feet. And so on. Some of those work packages could be estimated analogous. Well, this is some testing, it's some quality control work package. There's some testing involved. And this always costs us $4,000. So we can use an analysis estimate for that particular work package. Now there's another one on the list that I always talk about, which is the factored estimate. Here we're applying percentages. We know something about the estimate. We know something about an important part of the estimate, and we use percentages around that to come up with the whole estimate. A couple of examples are the following. You might be an engineer in some sort of a manufacturing plant, and maybe you do a lot of small projects around the plant. And for these small projects, you typically find out that on average, labor costs are equal to the materials that you're buying. So therefore, if you're estimating your next project, maybe you just do a quantity takeoff on the materials you'll need, price it, and make labor exactly the same. That doesn't sound very accurate, but maybe in the longer run you found that it does work out on average to be pretty close. Another example I see this is in certain kinds of studies. There might be, for example, a Part 1 environmental assessment has already been done by you in your company, and you know what it costs you. Now the customer is asking you for a Part 2 environmental assessment. And maybe you found out from experience that if you take a percentage of that Part 1 environmental assessment, maybe you can come up with a more accurate estimate of the Part 2 than if you tried to work it out from scratch in terms of how many hours it would take you to do it. Here's another example from my own projects. And this particular example I realized after doing these kinds of projects for several years that we did not have to spend the whole 3 months of a definition phase or planning phase to come up with the cost of the detailed design and installation of a major piece of equipment within my pulp and paper mills that I used to work on. Instead, we realized that we could come up much more quickly with the estimate. Our client, the pulp and paper manufacturing firm, would want to install a piece of major equipment as part of their paper machine. And we knew from our past project records that they would have already priced that piece of equipment from a manufacturer before they came to us, the engineering firm, to plan the project. So we found that from our records, if we took the price that they had been quoted and then we add percentages all around it for project management, for detailed engineering, for civil works, for mechanical works, for piping works, from electrical works, we could actually come up with an estimate of the whole detailed design and construction that would be just as accurate as a bottom-up estimate that might take us several weeks to prepare. So each of those 4 methods has its advantages and is best under certain circumstances. For an analogous estimate, this is where we're comparing it to the actual project we did in Montreal 2 years ago. It works well if the previous project is actually very similar, not too many adjustments have to be made, and we have good, accurate records of what the actual cost was. The parametric estimate, this is where some good measurable characteristic exists, and we've got good data on what does it usually cost per that measurable unit. Now, if you happen to be in construction and you're estimating construction costs using parametric data, this is very common. Of course, there's commercial databases involved that can tell you how many dollars per cubic meter or linear foot of piping. But of course, parametric can be used in all kinds of types of projects, as long as you have some measurable characteristic and some data on actual costs. The bottom-up estimate works if you do have a well-defined scope, you've got a good work breakdown structure, and it defines the whole project. Of course, it's also best if you've got good data to support your estimate of each one of those work packages. And the factored estimate is if you do have a firm quotation or a very strong estimate for some major deliverable on the project, such as that paper machine piece of equipment, or all of the materials you're going to use in your plant floor project, and you've got similar past projects from which you can get those percentages. Really, the key to estimating is having good cost records from past projects, preferably your own, but sometimes we can use records from other people's projects, such as commercially available databases. Now, there's the concept of 3-point estimates, and this is relevant for cost estimating as well as it's relevant for duration estimating as part of scheduling. Now, this method originated with PERT, Program Evaluation and Review Technique, in the 1950s. Now, PERT no longer is used, but we like to give credit to PERT for 2 or 3 things that we now do in project management by more sophisticated methods. So the 3-point estimating is a probabilistic, it involves some probabilistic method in estimating rather than deterministic. Instead of saying this work package we estimated to cost 2,000 labor hours, instead you would come up with 3 numbers. It's most likely to cost 2,000. It might cost 1,800 labor hours, and if it doesn't go so well, it might be 2,500 labor hours. And although in theory you may be able to get that data from having done this work package hundreds of times in the past and you have good statistical data, that's very unlikely. Really, you're most likely to be using this method using expert judgment of people that have done this work before and have a good feel for what that range of costs would be. And having started with then the optimistic, the low end of the range, the pessimistic, the high end of the range, and the most likely, the mode of the distribution. PERT gave us this simplified, abbreviated method of coming up with the expected cost, as you see in the numbers on my left. You take the optimistic, the pessimistic, 4 times the most likely, and you divide it all by 6. It's only an approximation, but heck, estimating is approximating the cost of your project. To look at it graphically, you're estimating the cost of the work package to be 2,000 labor hours, then you're adding on to that the optimistic end of the range. I think I said 1,800. The pessimistic end of the range, which I think I said was 2,500. You also have to pick a frequency distribution. Now, the old PERT method assumes a beta distribution. We like that because the curve comes right down to the axis at the pessimistic and the optimistic range. And it's a distribution that's nicely bulked around the most likely or the mode. And if you take a beta distribution, an approximation is the mean of that distribution, or the expected cost of that work package would be according to the formula that we showed you on the earlier slide. Now, I said that 3-point estimatings can be for cost or duration. We've been talking about cost, although expressed in labor hours instead of dollars. But I said that you could also use it for duration. So the duration of this work package, maybe the most likely would be 4 weeks, maybe the optimistic would be 3.5 weeks, maybe the pessimistic might be 5.5 weeks. You'll notice in the examples I've given you, it's always skewed because in real life, the pessimistic is usually estimated to be more off to the right than the pessimistic is to the left. Imagine this. Let's say you're estimating the cost or duration and your pessimistic end of the range is twice as much as the most likely. 100% more, in other words. Well, your optimistic end would not be 100% less because then it would be 0. The output from estimate cost, not surprisingly, is the cost estimate. And we should really always accompany a cost estimate with the basis of estimate. What was this estimate based on? Either write out what the scope is, inclusions or exclusions, although more likely that is your separate scope statement document. So refer to that scope document. What is included in the estimate and excluded in the estimate? How was it developed? Was it developed in a half an hour using an analogous method, or was it the result of 3 months of feasibility studies and a bottom-up estimate? It's rather important to say. And what are the assumptions and any constraints about it? Well, an assumption could be we're estimating this in $2,012 and without inflation. So now if the project comes to life in 2015, people will immediately know they should take that estimate and at least add 3 years of inflation to it and probably do some investigations to see whether it's still valid. Or constraints. The constraint might be this estimate was developed assuming we're using our own people, our own staff members, working part-time over a period of a year. It may be a little different if we had assumed that the project is being carried out by suppliers and contractors full-time over a period of 6 months, and so on. And what method was used for developing the estimate? I mentioned analogous. Of course, it could be parametric, it could be bottom-up. How was the contingency developed? Was there just a percentage applied to the estimate for contingency reserve? Were there specific risks that are envisaged? Maybe the cost estimate should refer readers to a risk register listing what were assumed as risks by your estimating methods. And importantly, what kind of accuracy range might apply to this estimate? Here's an example. Now, this hasn't happened to me. I have 2 different friends, colleagues, who have said, yes, they know of real examples such as I'm going to tell you right now. Imagine that you get into an elevator, and while you're going your couple of floors, there's a manager of another department in that elevator with you. And your department is a service department to her department. In other words, she is an internal customer of you and your colleagues. And she says, what would it cost to do, and she describes briefly what it is. Would you be able to get me an estimate this afternoon? And you say, well, yeah, I can get you an estimate this afternoon. It'll be pretty rough, but I'll have it to you at 3 o'clock. So you go to your cubicle, you work out using analogy and some past costs, and you provide an estimate by email. And of course, you just intend this to be very rough, order of magnitude estimate, high plus or minus accuracy, but maybe you don't say anything. It's sort of implied in this message that you've given her. You don't hear any more about it, and a year later, you get contacted by your department manager who says, congratulations, this project is going to be going ahead, and you are the project manager, and it's your estimate that they're going to use as your budget. Well, you didn't intend that to be a budget for approval of the project. You meant this to be a very early estimate, wide accuracy range, just for discussion and screening purposes. So when you provide an estimate, provide some sort of way of describing the accuracy and the other information that we've talked about in this basis of estimate. Basis of estimate is talked about by Project Management Institute in their PMBOK guide. It's talked about in much more detail by the Association for the Advancement of Cost Engineers, who have very good recommended practices with respect to cost and schedule on engineering projects. And that is cost estimating.